This video is about combining like terms. It's lesson 18 in your book, and it's on pages 98 to 102. Here's some definitions we need to know when we're talking about like terms. Like terms are two or more terms that have the same variable or variables raised to the same power. In like terms, the coefficients don't have to be the same, but every variable and every power needs to be the same. In unlike terms, we have different variables, or we have terms with the same variable or variables raised to a different power. So, for example, 3x squared would not be a like term as 3x to the fourth because they don't have the same powers on the variables. Here we want to combine some like terms without exponents. When we combine like terms, first we have to check, of course, and make sure that they're like terms. So we have to make sure we have the exact same variables to the exact same powers. If they are, we can simply combine their coefficients and write the variables and powers that they have once. In example 1 here, this needs to be in your notebook, it's part of your notes, we have 5x plus 7x. Now 5x has x to the first power, and 7x has x to the first power as its only variable and exponent. So these are like terms. In order to combine them, we simply combine their coefficients. So 5 plus 7 is 12. And then the variables and exponents they have in common are x. So 5x plus 7x is 12x. Here we've got negative 4y minus negative 3y plus 5y. Now these are all like terms because they all contain only y to the first power. So we can simply combine their coefficients. So we have negative 4y. I'm going to rewrite this without the minus the negative, by the way. So this is negative 4y minus a negative is really plus 3y, and then plus 5y. Now I combine coefficients left to right because it's adding left to right. So negative 3 plus 4 gives me a negative 1y. And then I've got my plus 5y over here. And negative 1 plus 5 is a positive 4y. Again, this whole page is examples. It needs to be in your notebook. In example 3, we've got 6xy minus 3a plus 4yx. Now, 3a is the oddball out here. It has a different variable than these other two terms. It's got a instead of x and y. So this is not a like term, and we're not going to be able to combine it with anything. However, it does still need to be in our answer. These first and last terms are 6xy and 4yx. Now, the variables are not in the same order. This one x is first and this one y is first. But they are the exact same variables. And they are also being taken to the exact same power. X to the first, x to the first, y to the first, y to the first. So they are like terms. So I want to combine 6xy plus 4yx. 6 plus 4 is 10. And then it doesn't matter which order I put the variables in. I can say xy or yx. I like xy better because it's alphabetically correct. And then I also need to put in my minus 3a here. Now on this page we're combining like terms, and these problems do have exponents. These examples need to be in your notebook as well. So here we've got x to the fifth plus y to the third plus x to the fifth plus y to the third. And we need to combine our like terms here. Here I have an x and an x, so that's good, they have the same variables. See how they also have, they're both to the fifth power, so these are like terms. Now I want to combine their coefficients, and anytime we don't have a coefficient in front of a term, we have an understood 1. So this is kind of like 1x to the fifth and 1x to the fifth. Now when I combine the coefficients, 1 plus 1 is 2. So here I have 2x to the fifth. Now I also have y to the third and y to the third. That's the same variable to the exact same power, so those are also like terms. And again, I have those understood ones. So I have 1y to the third plus 1y to the third. 1 plus 1 is a positive 2y to the third. Now I can't combine this term and this term because this one has an x and this one has a y, so they have different variables. So this is my simplified answer. In example 2 here, I've got 3k squared minus 2k squared plus 4k squared plus 2kx to the fourth plus kx to the fourth. Now this has a couple of different kinds of like terms. So what I'm going to do is I'm going to circle some sets of like terms, and I'm going to maybe put a square or a triangle around other sets. So first I have 3k squared. Now I can combine this with any other term that also has a k squared. So every k squared term I'm going to circle. Here's 3k squared. This one has a k squared, 2k squared. And then this one has a k squared, 4k squared. These are all like terms. They all have circles around them. Now this term is 2kx to the fourth, and I can combine it with every term that has kx to the fourth. So I'm going to draw rectangles around all my terms with kx to the fourth. Alright, now I can combine the circled terms all together and then the rectangle terms all together, and I'll have combined my like terms. So I've got 3k squared minus 2k squared plus 4k squared. So 3 minus 2 gives me 1k squared, plus 4 leaves me with 5, and what they had in common was k squared. Now for the kx to the fourth. 2kx to the fourth plus, and remember we have an understood 1 here, so 2 plus 1 is a positive 3kx to the fourth. And these two terms, even though they both have a k, they're not like terms because this one has k squared, this one's only k to the first, this one doesn't have any x's, but this one has x to the fourth, so we can't combine it any further, and that's our simplified solution. Now let's look at example 3 on this page. I have 2x squared y to the third plus xy plus y to the third x squared minus 5yx. Now, see how this term and this term, they both have x, y, but they're not like terms because this one, the x is squared, this one, the x is to the first. This one, the y is cubed, this one, the y is to the first. So since they have different exponents, these two are not like terms. Okay, so 2x squared y to the third I can combine with anything that has an x squared and a y to the third on it. So I'm going to circle my x squared y to the third terms. Now here we have negative 8 or minus 8 y to the third x squared. Notice this has the same variables as the first term, and each of those variables is being taken to the same power, x to the second, y to the third. So this is also a like term. So these are our two terms that we're going to combine first. I've got 2 minus 8, which gives me a negative 6. And then the variables and exponents they had in common were x squared, y to the third. Now you can put y to the third, x squared. Order doesn't really matter here because of the commutative property. Now here I have xy, and I can combine it with anything else that has an xy, so I'm going to do rectangles around these. There's a 1xy, so we have that understood 1 there. And here's a minus 5yx. Now these are like terms because they're the same variables and they're pulled to the first power. So I have positive 1 minus 5. 1 minus 5 is a negative 4. And those variables and exponents that they had in common were x to the first, y to the first. Now again, these have the same variables, but they're not to the same powers, so we can't combine them, and this is our simplified solution. Alright, this last one is about measurement. Another example, it needs to be in your notebook. Olympic competition offers 3 equestrian disciplines: dressage, show jumping, and endurance. The diagram represents the measurements for a regulation dressage arena. Find the perimeter of the arena as a simplified variable expression. Then evaluate the expression for x equals 19.5 meters. Alright, so the first thing we need to do is find the perimeter of the arena. Now this is a rectangle, and we know that to find the perimeter we use 2 times the length plus 2 times the width, or basically we add all the sides together. Now this tells me that the length is 3x plus 3, and that the width, w, is x minus 1. So I'm going to use my expression for perimeter, and everywhere I see an L, I'm going to plug in 3x plus 3. Everywhere I see a W, I'm going to plug in x minus 1. So I've got 2 times L, which I know is 3x plus 3, plus another 2 times the W, and I know W is x minus 1. Now to solve this, or to simplify it, I'm going to have to use my distributive property. So I'm going to multiply 2 by every term inside the set of parentheses. So I've got 2 times 3x, 2 times 3 is 6, so that gives me 6x. I've also got 2 times a positive 3, so that gives me 6. Then I've got a plus out here. 2 times x gives me a 2x. There's my minus, so I have plus a negative, which is minus. And 2 times 1 is 2. Now notice this says a simplified variable expression. This is one variable expression, this is another one. But in order to simplify it, we need to combine like terms. So notice I have a term with x here, x to the first, and then I've got another term with x to the first here. So these are like terms. 6x plus 2x, 6 plus 2 is 8, and then x. Now, I have a constant here, 6, and another constant here, 2. So 6 minus 2 is positive 4. So my simplified variable expression is 8x plus 4. That will give me the perimeter of the arena as a simplified variable expression. Now that's the first part. The next part says, evaluate the expression for x equals 19.5 meters. Now, my variable expression that I had was 8x plus 4. And this says x equals 19.5 meters. So everywhere I see an x in this problem, I'm going to plug in 19.5. So I have an 8, and then there's my x, so I'm going to substitute 19.5 in there, plus 4. Now to simplify this, first I'm going to do multiplication because that comes first in my order of operations. And 8 times 19.5 gives me 158. And then I've got plus 4, so finally I'll do my addition. 158 plus 4 is 162. Now I need some units, and I know perimeter measures length, and my length units here are meters, so my unit is meters. So that arena, if x is 19.5 meters, is 162 meters in perimeter.